Taking a more intensive look at how an attacker will go after your applications and focusing specifically on the Android platform, let's examine how to decompile an Android application. We want you to understand the ease with which an attacker can gain access to your application, its source code, and by extension, the application programming interface to the code running on the back end in your data center. We want you to understand the implications, how easy it is for an attacker to Trojan or introduce malicious code into your applications, and how easily they can reverse engineer your applications to understand your business logics and potentially secrets. So Android applications are written in the Java programming language, and when we build a Java application, we start with source code written in ASCII text, and we compile it into Android class files. These become the Java binaries. From that point, we're exercising a series of packaging steps, combining the class files into a jar file, and then bundling it with other components into the dalvec executable, which becomes the APK file that you download from the application store. So that's the important thing to remember, is the application store contains your APK file, the attacker can download it, and he can reverse this process. Attackers are resourceful, they're hackers. They get on the net and they find tools. So the attacker will use a tool called dex2jar to reverse part of this packaging process to translate the APK file into a dex file and then into a jar file. And he will use the jar command to unpackage the jar file into individual application class files, the components, and use a Java decompiler. In this case, we'll call it JAD, to decompile the source code or the Java class files into individual source code. Follow along with me as I show you how this works on a Unix command line environment. On your computers, you can duplicate this process using Windows equivalent tools. On your desktop, in the lower left, you'll see a folder labeled Decompiler Lab. Double-click to open it, and within that folder you'll find 3 folders labeled Step 1, Step 2, and Step 3. Open the Step 1 folder and you will find an mGov.apk application file and a file labeled Step 1 instructions.txt. Open the Step 1 instructions and follow the directions. It will tell you to rename the mGov.apk file to mGov.zip. Now watch carefully when you do this. You'll see that the icon for the file actually changes. And once you tell it to rename, you'll see a warning that says if you change the file extension, the file might become unusable. That's exactly what we want to do in this case. So say yes, click yes, and you'll notice that the icon changes to that of a compressed folder. Double click on that icon and you can see the contents of that compressed folder. You've essentially unzipped the file, as I did in the beginning step of my command line demonstration. You'll see the Android manifest.xml file. In this particular case, that's a binary XML, so you won't be able to read it. But the classes.dex file contain the classes components of our application, and the resources directory contains the resources as I described earlier. Go back up to the next directory and go into Step 2. Open the directions and follow them. It will tell you to double-click on the shortcut provided in the folder to open a command prompt. It's important that you use this shortcut because it will open in a specific directory with the execution path set to access the tools we're going to use. Once you're in that directory, type the following command: d2j.dex2jar.bat mgov.apk. This will do the dex to jar conversion process and produce a jar file. Once we're finished here, go into the next higher directory, go into Step 3, open the directions and follow them. It will tell you, double-click on the jdgui.exe file. This is a Java decompiler graphical user interface. It should look something like this when it opens. Once it's opened, click and drag the APK file into the decompiler, and you will see a hierarchy of folders appear on the left side. Click on the little plus marks to explore. I would start with the COM folder, go all the way to the end until you see an icon with a J. Click on that, and you will see that you have revealed the source code to the application. Yes, the attacker can do this. You just did it. It's that easy. What are the implications? All of these components must be signed. The APK is assigned a distinctive user ID, but the protection is provided by that digital signature. The authenticity of the application is provided by the digital signature. Since the Android and Google teams do not require a specific signature from a specific certificate authority, anyone can decompile, insert malicious code, and recompile an application. The only protections available at this point are a setting under security to disallow the loading of applications from untrusted locations. Users should never download applications from anywhere other than authorized application stores, and as developers, we should never encourage our users to doing that by providing access to our application except through the authorized development store. An example of a Trojan application found in the wild was Droid 09. This targeted some small and medium-sized banks in North America and imitated a legitimate banking application. What it actually did was steal the logon credentials from the user and transmit them to a location. You can see the message First Credit posted warning their users about this, saying, if you downloaded this app, please remove it and take it to your provider to make sure it's completely gone. And as a reminder, we don't even have a banking application for the Android platform. So the reference for this particular story is provided at the bottom. Thank you very much.